Okay.
I've never done that.
All right. So you might like today a little bit better than yesterday. Yesterday was all about limits with the table and looking at it graphically. Today we're going to do it algebraically. So you're going to like this a little bit better. Before we do the algebra, though, we need to learn about some properties. So back when you learned Algebra 1, do you remember learning properties like associative property, commutative property? If you don't, tutor one of those children, ask Tyler, he has to do all those properties again with them. All right, but
Don't forget to that's why Ty's so good.
exactly. There are 9 properties that I'm going to go over right now. You're going to look at them and it's going to look like a bunch of Greek stuff, but just don't worry. I'm going to help you out momentarily. Stop making me laugh. All right. We'll start off with the first one. Limit of a constant. The limit of a constant looks like this. If the limit as x approaches c of some value k, meaning some number, 3, 5, 10. Your answer is k. And let me just give you an example on the side here. I'm not going to do an example for each one, because when I do our actual problems, it'll make more sense. But if I said something like, the limit as x approaches -5 of 10, what would your answer be? 10. The limit of a constant is a constant.
Yeah.
Easy. All right. Property number 2. Limit of an identity function. Again, if you don't remember from Algebra 1 what identity is, the identity is your x, or 1. X approaching c of x. Okay. What do you think that would be? C. Let me give you an example of what I mean by that one. The limit as x approaches 2 of just x. Wouldn't you just plug in the number 2?
Yeah.
That's the limit. All right. So 2 very easy ones. Limit of a constant, limit of identity function. Moving on. This is the sum properties. Sum property. The limit as x approaches c of some function f of x plus another function g of x. Okay? Now, I hate to say it like this, but this is actually what you're doing. The limit of a sum, it's almost like you're distributing the limit to each piece. So it's the sum of the limits. So you would actually say the limit as x approaches c of just the f of x, and then add that to the limit as x approaches c of the g of x. If you don't know what I'm talking about here, just write it down. I promise you we'll go over it in a minute. Number 4, the difference property. What would be the only difference from here to here? Subtraction. So f of x minus g of x. What do you think the outcome would be? What would be the only difference here? Same exact thing with a minus in between. And again, I hate to say it's like distributing, but it kind of looks like that to me. Like you just distribute the limit. The limit as x approaches c of g of x.
Why do you hate to say it?
Well, because it's not the distribution property. So it's not mathematically correct, but it looks like that. All right, then we have this property called scalar multiple. Scalar multiple property. And this one looks like this. The limit as x approaches c of k times the function. So when you have like 2 times some quantity, x squared plus 5x plus whatever, you can actually take that k value out in front and then multiply it by the limit of the function.
Give me an example.
Yeah, we're going to do examples in a minute. Okay. There is a product property. What does product in mathematics mean?
Multiply.
Okay, so the limit as x approaches c of two functions that you are multiplying together. Based off of everything we've just done, I have a feeling you could finish this off. What do you think would be the answer, the limit here? What would you do? The limit of f of x. Correct.
It's just distributed.
Times the limit as x approaches c of g of x. See how they're all the same? And that's the beauty of mathematics. It just, to me, it makes sense. To others, it doesn't. It makes sense.
You trying to brag?
No. What comes after product?
Division?
Correct. Quotient. Don't get on my bad side. You could never. You could never. You could never. The limit as x approaches c of f of x divided by g of x. Now again, you should be able to finish this off with the mathematical brain that you have. What would that be? What would I do? Limit on the top of f of x divided by what? Limit on the I have no idea what that was. Good, two more properties, and then I'll do some examples. Yeah. Okay, this is called the power property. The limit as x approaches c of f of x raised to a power of n. Okay, if you see that, you are allowed to, according to the limit properties, you can take the limit of the function, notice that's what we've been doing with every single one, and then raise it to the nth property. So you're allowed to take the limit of each function and then do whatever operation you have to afterwards. And that leads us to our last and final property, and then we will put all these together. The nth root property. The limit as x approaches c of the nth root of the function. I have a feeling you would know how to write this without me finishing it, but anybody want to try it for it? What would you do? What have I been doing in every single... The limit is of f of x as x approaches c, and then do what to that?
1/2 or n.
And then nth root it, or to the 1 over n, you could say it like that if you want to, or to whatever. Yeah. That's called the nth root. Okay, now, why do we do all these properties? So let me be real with you. In your typical calculus class, they would make you use these properties for every problem in the beginning of limits. I'm going to show you the first example using those properties, but I'm going to be nice to you because my calculus teacher was not that nice. He made us do every property every time when we first learned limits. It was painful. You had to actually write out the property that you're using. I'm now using the quotient. Now I'm using the scalar multiple. Now I'm using, it was a proof. Yeah, exactly. So I'm going to show you on the first example, but then I'm going to give you all the tricks.
Well, then you memorize it all. You should make us do that.
No, because you're going to see after this first one why it almost becomes unnecessary. All right, so here you go. The limit as x approaches 4 of x squared minus 6x plus 3. And I'm going to use the properties, and then I'm going to show you the trick. Actually, you're going to kind of discover the trick yourself. So according to the sum property and difference property, you are allowed to take the limit of each of these, aren't you? Mm-hmm. So that would be the first thing I do. The limit as x approaches 4 of x squared minus the limit as x approaches 4 of 6x, plus the limit as x approaches 4 of 3. So kind of like distribution. I take the limit of each one, okay? This one right here with the squared, isn't that the power property, right? Something squared. So I'm allowed to just write this as a limit and then square it. So I'm actually going to rewrite this as the limit as x approaches 4 of just x, and then square it. This one right here is a scalar. There's a number in front. So I'm going to pull that number out to the front, and I'm going to write minus 6 times the limit as x approaches 4 of x. And then this one, there's really nothing you can do here. The limit as x approaches 4 of 3. Now, isn't this the limit of a constant? This was our first property I wrote. What is the limit as x approaches 4 of 3?
3.
Just 3. This one, ignore everything else. This was our second property I made you write. The limit as x approaches 4 of x. What's that answer?
4.
4. And then multiply it by the scalar, 6.
20.
This one, isn't that the same as the second property right there? What would the answer to that one be? 4 squared. Okay, question. What does this right here look like? What did you just do right here? Plugged in 4. Why should I do all this, Mrs. Setta, when I can just plug in 4? I mean, and that was what frustrated me the most when I had calculus. But like I said, this is what we had to do every time. But your job is to do this first. Plug it in. Your first step in limits every time is plug it in, 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 plug it in. What is the answer, by the way? 16 minus 24 plus 3? Negative 5? Yeah, that's the limit. Okay? So on tonight's homework, step 1, plug it in. You do not have to do all this. Thank you, Mrs. Setta. Thank you, Mrs. Setta. Okay? Plug it in. Yes, thank you. Okay? So do this one. Tell me what this limit is right now, and then tell me what this limit is also. Oh, there will be, and that's the first step I want you to do every time is plug it in, plug it in. So plug it in right now and tell me what your limit is. Plug it in right here and tell me what your limit is. Sometimes your limits can just be weird numbers and they're not always like decimals. Just get me the exact answer if you can. The exact answer is actually always better. So plug in negative 2. Everywhere you see an x. 4 times negative 2 cubed plus 1 over negative 2 plus 5. Tell me what you get out. That's the answer. That's the limit. Done. Half of your homework is going to be like this. Okay? How about this one? What's this one going to be? Square root of 8 minus 3. What is it? Square root of 5. Done. That's the limit. You don't have to check the table. You don't have to do anything. That is your limit. Now, Carson just asked a great question, or Lane. I'm sorry if I can't remember. It was Lane. Are we always going to be able to plug it in? Were we always yesterday able to plug it in, kids?
Yes, we were.
I'm sorry. Were we always yesterday allowed to plug it in?
No.
No. So let's do some of those, shall we? No, we're not even on the infinity ones yet.
All right, we're good.
Okay.
Oh, gosh.
He dropped something.
You got your face.
I blame my sister.
Okay. The limit as x approaches negative 4 of this. Okay, so let's just start right here. You don't really even need to plug it into the top when it's a fraction. Because if you plug it into the bottom, what do you get right now? Are you allowed 0 in the bottom? Okay, so do not be tempted to write, DNA, Mrs. Setta, it does not exist. No, don't you dare. You have to do something else before you even write DNA. So here's what you're allowed to do. This should look familiar to you, kids. Don't you want to do something to me? It's trinomial. I want a factor. Let's do that. What two numbers multiply to negative 20 but add to negative 1? Wait, what? Negative 5 and positive 4? And what are you allowed to do from top to bottom?
Get rid of it.
So what is the limit as x approaches negative 4 of just this one? Could I plug it in now? What's negative 4 minus 5? Negative 9. That is the limit. Your second job, if you plug it in and it doesn't work, you then need to second step you need to do is factor. Factor, factor, factor.
Factor.
Okay?
I just plugged in -4 straight into x squared minus x plus 2.
And into the bottom, though, the bottom you would get 0. You can't have that. So that's why you have to factor. All right, do this one. Limit as x approaches 3 of x minus 3 over x cubed minus 3x squared minus 7x plus 21. Let's see, if Miss Etta gave you an example of factoring on the previous one, what do you think you're going to have to do now? Factor. Do you know how to factor this bottom one, by the way?
Yeah.
Miss Davis calls it Fantastic Four. Come on, factor. Guys, participate. I'm still not done.
What are we doing?
Factoring.
Oh, I zoned out for a second.
I know. Come back to me.
It's 1.
Would you factor out a -7 or just a
I'd factor out a -7.
They're same on the bottom.
Okay. Jed, what can you factor out from here? I'll do it with you. X squared, what are you left with? X minus 3. What factor out from here? What are you left with?
X minus 3.
How do you rewrite this?
X squared minus 7. X minus 3.
Okay. These will cancel. Be careful. The top cancels out with the bottom. It does not leave you with the top of 0. What's on the top? 1 over x squared minus 7. Now take the limit. Now plug in a 3. I would get 1 over 9 minus 7, which is 1/2. That is the limit. You've got to factor. That is your second step. So step number 1, plug it in, plug it in. Step number 2, factor it. Step number 3 is only going to occur when you have radicals. So the limit as x approaches 9 of the square root of x minus 3 over x minus 9. Again, if you plug 9 into the bottom, would you not get a 0? Okay. So when you have radicals, you have to do this thing which we did way back in the beginning called rationalize. Even though the radical's on top, you're still going to try to rationalize it to the bottom. So that is your third step on tonight's homework, rationalize. Only if it has like a square root, really. Multiply the top and bottom by the conjugate. What is the conjugate of the top?
Root x plus 3.
Okay. Foil the top, do not foil the bottom. Let me say that again. Foil the top, do not foil the bottom. You'll see why. And actually, you don't really foil, you fla. Okay? So square root of x times square root of x is just what? X. Minus 3 times a positive 3 is a minus what? 9. Oh, don't I have an x minus 9 on the bottom?
No.
So those are going to cancel. And you are going to take the limit now as x approaches 9 of 1 over root x plus 3. That's it. 1 over the square root of 9 plus 3, which is 1 over 6. That is the limit. How are you doing on this? Okay, let me just stop because it's about to get longer and I just want to stop right now. I'm going to brief